So I go forward in English. So I did a presentation that started with all these things that our colleagues have already showed to you, so I will skip the first part, and I will try to talk a little bit on lab, but also on in situ evaluations and the recent approach that I would like to share with you. So this is a mechanical issue. We have heard Alessandro and others telling that it's a question of state. Granular, non-plastic soils and the state is a mechanical issue. So we will work with mechanical tests in order to evaluate this risk assessment. So we are worried in Liquefact more than lifelines and surface structures, how they may stand, and we heard about the resilience, and that's why we are focused on surface areas and profiles. And we have already seen this, and this we didn't have, but we know that in Japan was terrible, most in lifelines and surface infrastructures, and this is what I would eventually exclusively talk to you, but I will also talk a little bit on in situ tests. So laboratory is good. It's good because we control all the tests. We know people from the lab rats. We know that we can control almost everything on the frontiers, the border conditions, the stress state, even the saturation level, which was here focused by Alessandro, which is a very important issue that we will try to deal with our project, both in Porto and Naples, etc. But do we have good quality samples? We will try to evaluate that also. It's very difficult to do what you have seen here. Most of you know some of these pictures from Mike Jamelkov's, our very good friend, that were collected in Messina Bridge for the project, but it's very expensive. So we have to freeze the soils and get it out. So it's really a very time-consuming and complicated issue. Recently, some other alternatives appear, and this is a gel push sampler, which I learned from people that are using this. Is not so complicated. It's just an evolution of the Osterberg sampler, which I think some of you know, or the Mazier sampler, one more for clays and fine materials and the other for more coarse and structured materials, with some gel push, scheme. And this gel is something that we can use eventually in some of our other tools like the Mazier or the Osterberg. But in our project we will deal with this. We will also deal with this because our partner Trevi has this implemented, and we will try to look at the importance of the sampling when we do lab tests. If we have those destructured, I mean, we have all the safety side, but it's not the representative. So what usually people do, we tamp the material, we reproduce the density of the material, we eventually do pluviation, nice techniques, but the structure, the natural structure of the soil is lost. We are on the safe side. Yes, we are, but we are not on the economical side, which is also very important, so we can be very aggravating the conditions. We have a lot of laboratory procedures, triaxial equipment, oh, so many, so nice, so very well controlled, but we do believe that usually cyclic simple shear tests are more representative, as some people know here, others not so much. And that's what we will focus also, is to compare how triaxial do not represent in very specific and general conditions our shaking movements that we have on the soils, on the grounds, and on the liquefaction approach when they turn to be. So we have these everywhere. Ismageo has their own facilities. We have also, and Naples also, we will be working together looking at that. So cyclic triaxial tests, they are good, but come on, they do not represent, as the cyclic direct shear sample or simple shear tests, the reality of our shaking. So I should talk a little bit on lab, that's what I'm doing. So equipments are available, we will test these, and we will try to orient the labs to do the ideal conditions if they want to do lab tests. So for people that don't know what is this, Vincenzo has already showed, so I will skip. No, I will not completely skip, but the idea is this. We have to rule our tests with a very simple index that is related to the torsional shear, the shear stress that is inherent or is consequence of a spectra. And this is what we usually do. We will have to translate this cyclic stress ratio in the triaxial test by a deviatoric stress, because we only do that in the triaxial. We can do that also, but it's very complicated. And we get these examples that you have here. We will talk in a minute of the number of cycles and what we do with the number of cycles, which Vincenzo has already showed to you. But if we do cyclic shear tests, that we will be much more faithful to the reality. And that's what we have. It's directly a consequence of the shear cyclic stress, which is the dominant in our soils. This is what we have. I will not detail this, but still we have always to go forward to this. Where is liquefaction? Is when excess pore pressure, it was well in Italian explained by Vincenzo, gets into the value that is equal to the effective stress. It fails. It's liquid. But traditionally, we have an alternative which is always also as put as we can have problems when this, after a kind of number of cycles that represent the earthquake, is too big, is too much. And most of our liquefaction approach rely on shear strain of 5%. Is this liquefaction? Well, it is not a pure liquefaction, but it's so bad. It's so strong, it's so unsustainable in our structures that we also have proposals that integrate the same concept, and it is not pure liquefaction. And that we should be aware of. Some abacus tend to be a little bit different because people use the one and the others use the others. So we have to be aware of that. Please, those people that work with lab, please be aware of that. So this is what we should do. Finally, and in the consequence, finally, in this area, in the consequence of what Vincenzo told us, we do have a trend that when materials increase in their quality, look, void ratios of 0.87, 78, 71, 61, is getting denser. So if you do all these tools, we play with these tools in the laboratory, you will have, with this density, this pattern of behavior. So this material is confined with different conditions, with the same void ratio, and you get all this evolution in depth. I mean, you're getting from the shallow to deeper areas. But the material is denser, it will be much more denser, looser, much more unstable. And so in the end, you look at this and what shall I do? I mean, then you have the reference number of cycles that represent your seismic, usually by default 10 to 15 cycles, because it's 1 Hertz to 1.5 Hertz, our spectra. And you will look for your condition, where is the state that gives you the failure. This can be done in simple shear as in triaxial tests. And look at the amount of corrections that we have to do in triaxial tests. Corrections are usually empirical, so it's better to avoid. So triaxial tests have all these defaults, and I am a rat from the lab, but also by in situ, and have a lot of triaxial tests, but I do recognize this. But what is this CSR and CRR? Vincenzo has already explained to us, so I will skip this. It's just an index of action, CSR, stress ratio, while the RR is the resistance of that material for that condition, for that shearing. So always do distinguish CSR and CRR. So, and then we have some magnitude corrections that I will try to skip. It's easy to adapt your seismic, your magnitude of 5 to the reference one. And which is the one that is the reference? It's 7.5. Why? Because it's really very, very strong. And that's what people did. But if you have less, we can adapt. So for those that are dealing the first time with us, don't be afraid. It's just a question of skipping that. We have some other correction factors that I would like to focus, but I will have time, which is the stress-dependent. Vincenzo has a revolutionary proposal here. We should be in one of these congress of earthquake technical engineering. There were people standing already. Idris and Bologna were standing. But that's what we will do also in Liquefact, is try to confirm these different shape factors, and mostly related to this factor that we have here. This is the key issue that Vincenzo told you. I don't know if you understand, but that's the problem. So, but it would be nice for us to prove the opposite of all the thousands of curves that the colleagues have. And then we have also, if you have a slope, are you expecting for the same material that it will fail from the same conditions? Eventually not, because it's inclined. So this K alpha is what you have to do when you have an inclined surface, which is much more unstable than the horizontal one. Even for collapse, even for settlement. I'm not talking only of lateral spreading. So let's go on. So in the end, we had already this state parameter introduced by my good friend Vincenzo, so I will not talk about this. And it's really very well connected with that failure zone. So all the points that have here are high values of the state parameter. Wet side for the English, which does not mean that the dry side, the one that is good, is dry. It is not dry. The English simply separated the wet side is the bad side and the dry side is the good side. But all these are saturated. If we want to ameliorate from non-saturated conditions, we will work on this state a little bit tricky. So we have to do some other lines. There you go. So this is what we usually have. So this is the kind of tools that you can joke with for any evaluation. But there's so many. Usually we just do 2 or 3 that we rely on because they are universal. So in situ test is good because it's easier, and it can get more information in the same region. So what we have this profile, we have problems here. We could do borehole logging, but it's so complicated. The Japanese like a lot to do this and put there the instruments and then do some kind of micro excitation. But we usually use cone penetration tests because they are so much calibrated. And that's what we heard about. It's just a simplified procedure. We are looking from the cones or from SPT. I don't like SPT, sorry, it's terrible. It's very variable, it's so much time human dependent, but the cones, the CPT are okay. You have all these simplified procedures, which is here described, but in the end it's just a question of looking at the action, and you get this index that they put in abacus, in lines. So, this is just an idea for those that don't know Portugal. We are really very, very, very high seismic zone. So let me just go. This is the scheme that you can follow in CPT tests. And it's very clear now with all these state parameters that Vincenzo told us about. These are the 2 main deterministic SPT and CPT-based triggering. They used to be very empirical, but now there are a lot of works coming out from these same people that studied a lot of this, the appropriateness of any triggering KC value for specific stratum in case histories, interpretations, or forward analysis depend on the special characteristics of the strata. There are a lot of geologists here, so this is good for you. They did all this work by doing some a kind of a random analysis, and then finally they got these curves. They are so similar to the ones that they proposed in 2008, although different from Vincenzo. But in the end, what they said is that the ones this is probabilistic for liquefaction. The 15 value is really almost the ones that were in the classical, and then I invited you to read this report from then, which is great. We were working with 15% of probability of failure with the classical ones coming from 2008, except for the exception of Vincenzo. So I will not have more time. I will just say that DMT is also very nice, and it is an Italian tool. and it has been proved to be very sensitive to cementation, and more than cementation, things that I didn't heard here, stress history. Because stress history is not cementation. Stress history is over-consolidation. And that's the KD of the DMT or others, like pressure emitters, but we don't like pressure emitters here, the French like. They are very sensitive to that. So in the end, VS and DMT can help us to do all the necessary liquefaction potential index. No one told you about this, but this is the things that we will use in our approach for vulnerability. But I don't have time. I will try eventually to get back this last slide this afternoon. Thank you so much.